2-5 Algebraic Proofs. So a proof is an argument that uses logic, definitions, properties, and previously proven statements to show that a conclusion is true. An important part of writing a proof is giving justifications. And justifications are used to show that every step is valid. So some justifications here would be our properties of equality. Our addition, subtraction, multiplication, and division property of equality say that if A equals B, then we could add, subtract, multiply, or divide both sides by the same value, and our equation is still going to be true. The reflexive property of equality tells us that everything is equal to itself. The symmetric property of equality says if A equals B, then B equals A, that we can flip our two sides of our equation and it's still going to be true. The transitive property of equality says if A equals B and B equals C, then A equals C. And then the substitution property of equality says if A equals B, then B can be substituted for A in any expression. Lastly, we also have our distributive property, which says if we have A times B plus C, we're going to distribute or multiply A to both B and C to get A times B plus A times C. Whenever we solve a problem in algebra, we are actually doing a proof. So we'd like to demonstrate that by solving the equations below and writing a justification for each of our steps. So if we have 4m minus 8 equals negative 12, remember whenever we're solving an equation, we want all of our variables on one side or all of our letters and all of our constants or numbers on the other side. So we already have 4m being the only thing with a variable on the left side. So we're going to leave that there and we want to move the negative 8 over. So I'm going to do the opposite. I'm going to add 8 to both sides. Okay, if I'm looking at my properties up here, I am using the addition property of equality. So I'm going to label that here. I'm using the addition property. On the left side of my equation, I'm going to be left with 4m, and on the right, negative 12 plus 8 leaves me with negative 4. Okay, to get m alone, I'm going to divide both sides by 4, which is using the division property. And that gets me m equals negative 1 as my solution. Okay, we can do the same thing with b. If I have 1/2 t equals negative 7, I'm going to get t alone. I'm going to divide both sides by half. On the left, I'm going to get t alone, and on the right, I'm going to get negative 13, which is going to be my solution. And then recall we want to justify each of our steps, so we used our division property here. All right, number 2 asks us to write a justification for each completed step. So it looks like we have a segment here. We have segment KM, that is 5x minus 4. We have KL, which is x plus 3, and LM, which is 2x minus 1. Our first step, it says, is KM equals KL plus LM, which we remember from last chapter is our segment addition postulate. All right, from there, it looks like we replace KM with 5x minus 4, we replace KL with x plus 3, and we replace LM with 2x minus 1. This is using our substitution property of equality. Then it looks like on the right side here, we simplify that by combining our like terms. In our next step, it looks like this 3x goes missing from the right side because we subtract it over to the left. So there's our subtraction property. Right, after that, I'm looking and this negative 4 disappears from the left side because it's added over to the right. So there's our addition property. And lastly, we go from 2x equals 6 to x equals 3. So we're dividing both sides by 2 using our division property. All right, we're going to leave B for in class, so skip that one for now. A couple more justifications here. These are properties of congruence. A reflexive property of congruence is very similar to our reflexive property of equality. It says that figure A is going to be congruent to figure A, so something's going to be congruent to itself. The symmetric property of congruence is also very familiar. It says figure A is congruent to figure B, then figure B has to be congruent to figure A. And the transitive property of congruence, once again, pretty familiar. If figure A is congruent to figure B and figure B is congruent to figure C, then figure A is congruent to figure C. All right, this last little bit here asks us to identify the property that justifies each statement. So we're told that angle QRS is congruent to angle QRS. That would be our reflexive. And in this case, it looks like of congruence. Okay, B, we're told the measure of angle 1 equals the measure of angle 2. So the measure of angle 2 equals the measure of angle 1. There's our symmetric property. Okay, C says that segment AB is congruent to segment CD, and segment CD is congruent to segment EF, so segment AB is congruent to segment EF. That would be our transitive property. Once again, of congruence. And then lastly, we're told 32 degrees equals 32 degrees, and there is our reflexive property again. All right, good job, y'all. See y'all in class tomorrow.